Design case study for solar home systems for the AC loads. In this case study, in this session, we're going to be talk about basically if the consumer is using the AC load at the load end side actually, then how we can design the solar home systems. In the earlier case study, we have seen that if a consumer is using the DC load, how we are sizing the solar panel, how we are calculating the sizing of the solar charge controller and corresponding battery over here. So one by one, we're going to see the problem statement. Then we can see the load table over here. So the problem statement is the design of the AC solar home system for the given load shown in the following table, which is used by the small home systems. Design a AC solar home system in such a way that it should satisfy the need of the consumer. So basically, whenever we want to design any kind of a solar home system, we have to visit the site, and accordingly that we have to just check out how many numbers of the instrument or how many numbers of the equipment the consumer is utilizing. So in this case, the consumer is using the fan, LED TV, LED light, tube light, and the refrigerator over here actually. So the fan wattage is the 75, LED light wattage is the 15, tube light is consuming the 40 wattage, LED TV is consuming the 80 wattage, and refrigerator is consuming the 180 wattage. So this is a wattage of the individual equipment that the consumer is using. Total number of quantity of fans are 3, LED lights are 5, tube lights are 3, LED TV is 1, and refrigerator is 1. So we just multiply by the individual watt to the quantity, we will get the answer of the load for the total numbers of the fan, the LED light, total numbers of the LED lights. So like that we can calculate simply multiplying the power watt rating into the quantities. So from that we can calculate the total load requirement for the consumer whenever he is using all the equipment at a one time. So what amount of the load has been consumed by the consumer in terms of the watt. In the last column, it has been mentioned the duty cycle. So we have to ask the consumer, rather accordingly, we take an assumption over here. So how much time the fan will going to run down, how much time the LED light will going to work it out over here, tube light working position, LED TV, and the refrigerator position over here. So simply the duty hours in terms of the hours we have to be note down over here. Then we can do the further calculations over here. So now in this case study, we're going to start with the watt hour consumption calculation in this case. So basically we have taken all these equipments, power rating, quantities, load in terms of the wattage, the duty cycle. We're going to add the last column, the load consumption of the consumer in terms of the watt hour. This is required whenever we calculating the number of unit consumption on the daily basis in terms of the kilowatt hour, and the solar power plant capacity in terms of the kilowatt. So simply the load of the fan multiplied by the duty cycle of the fan, we multiply, we will get the answer of 1350. Similarly, the 75 multiplied by 8, we are getting the answer of 600. Like a 120 multiplied by 8, we are getting the answer of 960. So simply we multiply the watt value into the number of hour of the working cycle. We'll get the watt hour of the consumption for each and every equipment. It has been noted down over here. So when we add all these values over here, actually, whatever the watt hour consumption it will have, we will get the total watt hour consumption on the daily basis is the 5030 watt hour actually. So the consumer daily basis, he is consuming the 5350 watt hour, this much amount of the load over here actually. So whenever we divide this load by 1000, we will getting the answer in terms of the kilowatt hour actually. So we'll get the answer of 5.030 kilowatt hour. So in a one day, the consumer requires 5.03 kilowatt hour of the unit for consumption. So now whenever we want to calculate the solar power plant capacity for installation, we will use the thumb rule, as in 1 kilowatt of the solar installation requires or produces the 4 numbers of the unit in one day. The unit of this unit is in kilowatt hour over here actually. So on an average, we consider the thumb rule that 1 kilowatt produces the 4 units. Then for production of the 5.03 kilowatt hour of the unit, how much capacity of power plant will be feasible for that. So we just do this calculation, or simply whatever the value we have got over here, which is our 5.030 kilowatt hour divided by the 4. So from this calculation, we get an answer of 1.25 kilowatt. So we have to require to design the 1.25 kilowatt of the solar home system for the consumer to satisfy this much load requirement of the consumer. So once we have decided the kilowatt hour of the requirement, once we have decided the solar home system sizing, so we just convert this kilowatt into the watt over here. So it is a 1250 wattage of the solar home systems we have to design to satisfy the consumer load requirement. So for that purpose, we have to select the solar panel. There are various manufacturers are available in the market who can producing the solar panels actually. So we're going to select the 325 watt peak of the solar panel, who is the Vari Private Limited is the manufacturer of this particular solar panel. So we have to look out the data sheet of the solar panel and we have to note it down this much parameter. First is the peak capacity of the solar panel, which is a 325 watt peak. Maximum power point voltage, which is a 37.2 volt. Maximum power point current is 8.72 ampere. Open circuit voltage of the panel is 45 volt. Short circuit current of the panel is 9.16. Maximum series fuse rating is the 20 ampere. And efficiency of a module is 16.70% over here. Generally, whenever any solar manufacturer or solar panel manufacturer is giving the datasheet, actually, he is mentioning that like a 100 watt peak of the solar panel in a bracket, this is a 12 volt. So it is a rated voltage they are giving, but in actual cases, in the maximum power point voltage is 37.2. Similarly, for 325 watt peak of the solar panel, the rated voltage is your 24 volt, but in actual cases it is giving the 37.2 volt over here. For calculation of the solar charge controller sizing, we're going to select this much amount of the voltage, but the rated voltage of the standard particular solar panel is the 24 volt over here. So once we have just decided which solar panel we have to be concluded or we have to be taken into the consideration over here, now we're going to calculate the number of solar panel in the system. Number of solar panel is nothing but the solar power plant capacity. So whatever the solar home system we are designing, so capacity of the solar home system in terms of the watt, that is a daily basis consumption we are taking. So in terms of the watt, we are just noted down over here and divided by the individual panel rating we have to be selected over here. So individual panel rating will going to be select over here. So the solar home system wattage size, it is a 1.25 kilowatt. In terms of the watt, it is 1250 watt over here actually. Divided by the individual panel rating, it is our 325 watt. So from that purpose, we are getting the answer of 3.84 over here. So close to the 4, we can choose the numbers of the solar panel in the system actually. Once we have decided how many numbers of the solar panels are required in the system, now we can decide how we can connect this panel in the series or parallel combination over here. As good as we have seen in the earlier case study, whenever we are connecting the solar panel in the series combination, so basically in series combination, positive of a 1 we are connecting to the negative, so like that we are doing the connection. In this case, the voltage is continuously increasing, but the current will remain same over here actually. But whenever we join the solar panels in the parallel combination, like in the diagram it has been shown, the positive of the each wire of a panel we are combining at a one wire, and negative of each wire we are combining at a combined wire over here. So this is the output terminal we can measure with the help of the multimeter. So in this parallel combination, the current is increasing actually always, and the voltage will remain same over here. So now, as per our designing has been concerned over here, we have to just design over here actually that if we are connecting the 4 numbers of the solar panel in the series combination, parallel combination over here, what could be the voltage and the current we are getting at the end side over here actually. So we know the voltage of each solar panel is 37.2 volt. Current of each solar panel is 8.72 ampere. Then if we are connecting the 4 panels in the parallel combination mode over here, so the current will increasing over here actually. So 8.72 ampere multiplied by 4, we are getting the total current is 34.88 ampere whenever we measure with the help of the multimeter at this end actually. And the voltage will remain same, which is 37.2 volt. there is a reason actually why we are connecting the panels in the parallel combination, because whichever charge controller we select from the market actually, it is always having the standard rating of the 12 volt, 24 volt, 48 volt, 96 volt. So that is why we have to select the voltages of the solar panel in a such a way that, or the feeding voltage of a solar panel to the controller in a such a way that it could satisfy the voltage range near about the standard ratings of the solar charge controller over here. So once we have connected the panels in the parallel combination, we can go for sizing of the solar charge controller over here. So basically, the current that we are feeding from the array to the controller, it is a 34.88 ampere. So basically, we just multiply this value by 1.25 as a design margin, and we get an answer of 43.6 ampere over here actually. So whichever standard according to the market condition, whichever solar charge controller is near about these ampere ranges, that we can easily select over here. So basically the voltage that we are feeding to the solar charge controller, the maximum voltage is 37.47 volt over here actually, the maximum voltage that we are feeding. But now whenever in the morning situation, when we see the situation over here actually, we will get the voltage here near about the 24 volt. In the late afternoon situation, we are getting the voltage near about 36 volt. Again in the evening situation, we are getting the voltage near about 22 volt. So basically actually, whatever the voltage it is getting generated by the solar panel, it is always varying in the range actually. So that is why whichever solar charge controller we are taking, so close to that we have to choose the rating of the solar charge controller. So that if we are selecting the 24 volt solar charge controller, it can able to handle the voltage from 1 volt up to the max to max voltage near about 30 to 35 voltage over here. So basically every solar charge controller will have their own limit of the accepting the maximum amount of the voltage. So if we are going for the maximum power point technology of the solar charge controller, we can feed the series combination, or the 2-3 panels we can connect in the series combination, then also we can feed and we can decrease the amperage rating over here. But whenever we try to select the solar charge controller, so we try to select closer to the market rating, which is the 12 volt, 24 volt and 48 volt. So basically, if we are selecting the solar charge controller of the 24 volt of the sizing, then the battery bank voltage must be the 24 volt. It means what? If the solar charge controller is having the rated voltage of the 24 volt, it will going to charge the battery at a rated voltage of 24 volt only. So that is why whenever we do the connections of the battery, so according to that we have to adjust the battery bank voltage near about the 24 volt over here. Then the system will going to run smoothly over here actually. So that is why this is the main reason why we could select the 24 volt and the 60 ampere of the solar charge controller. 60 ampere is because whatever the market easiest available solar charge controller will be, so around the market we will find it is a 60 ampere charge controller has been available for the Micromatic company over here actually. So that we can select now the 24 volt 60 ampere solar charge controller for the further designing purpose.